Hello everybody and welcome to today's video where I'm going to be showing off the flow field that I created using Unity's data-oriented technology stack and their entity component system. Now this is actually the third video in a series of videos that I'm doing based off of goal-based vector field pathfinding, aka flow field pathfinding. Now if you don't know what flow field pathfinding is, you can see an example of one playing in the background behind me. And if you'd like a more in-depth breakdown on what exactly a flow field is and some of the advantages of using a flow field, definitely check out the first video in the series where I go into detail on what that is, as well as how the algorithm works under the hood. Also, if you are interested to see how this works in code, I did create a tutorial where I show you how to implement this in Unity using traditional mono behaviors. I'll go ahead and link that video up in the card as well as in the description below. And now that brings us to today's video. So I initially had intended to make this another tutorial video as well, where I basically show you how to implement a flow field using Unity's data-oriented technology stack. Now, I'm not going to lie with you guys, I struggled quite a bit on making this project. The mono behavior flow field, I was able to implement that pretty quickly. I was able to get the majority of it all working within a day, and then just had like another day for like cleaning up the code. This data-oriented technology stack one, I've actually been working on it for about 2 weeks now, and have spent a whole lot of time just trying to like figure out what is the best way to do this for the best possible performance. Because at the very core of the data-oriented technology stack is that it's about performance. So it ended up taking me quite a while to figure out how I wanted to do things, and ended up kind of cheating and cutting corners in a couple areas, which I will point out. So I don't want this to necessarily be like a tutorial video where I say like, you know, this is the definitive way to create a flow field using ECS and Unity's data-oriented technology stack, but I still did want to share what I created and kind of go through my thought process of how I created it and why I created things in the way that I did. So I'm not going to be going through everything, you know, exactly line by line, but I will be going through all the major steps. Of course, I will have all the code and project files available for you to download using some links down in the description below. Now, as far as the actual results for the performance, I'm going to go ahead and leave that for the next video in the series. Like I mentioned that, you know, this is going to be an ongoing series, and the final video in the series is where I'm actually going to be doing a bit of a performance comparison. I'm going to be comparing the performance between just the standard regular Unity mono behavior implementation, the dots implementation, which I'm going to be showing off today, as well as a hybrid implementation, which I'm going to be creating as kind of a hybrid between the two. So anyways, make sure you are subscribed to the channel so you don't miss that video when it goes live. Of course, if you do enjoy today's video, I'd really appreciate it if you hit that like button. And hey, if you do have any questions for me or suggestions for any future videos, or maybe any video series that you'd like to see, feel free to leave those down in the comment section below. All right, so we're going to start over in Unity, and I'm just going to give you a quick overview about how I have the Unity project set up. And if you watched the previous video about when I implemented this using Unity mono behaviors, you'll see that it's quite similar. Some minor differences are some of these things in the hierarchy, such as this grid controller. We do have the convert to entity component attached to it. So some of these things are actually going to be converted to entities at runtime. And so if we go into the world container and we look at something like one of these cubes here, you'll see that I do have the convert to entity script. However, it is set to conversion mode of convert and inject game object. Now, the reason I'm going to be doing that is because I'm still calculating the cost field using Unity mono behaviors. And the reason I'm doing that is because Unity's new physics system currently does not support the overlap box function, which is what I was using to check all the cells to see if they were touching one of these walls or this kind of rough terrain area here. The closest equivalent I could find was overlap AABB, which of course stands for Axis Aligned Bounding Box. Now, the overlap AABB function works perfectly well when I'm trying to target something that is an axis aligned box such as this. However, when we turn the box at an angle, now see the AABB contains several cells that are actually not touching that impassable wall. So this runs into a problem because it actually marks all those cells within that AABB as impassable. So the workaround that I came up with is to just have a mono behavior calculate the cost field in the same way that I did in the normal Unity implementation, just using the physics.overlap box function. So bringing it back to the reason why we have the convert and inject game object is because this will not only spawn an entity in the world, but it will also keep that game object in the world. So we can use that game object as a target to do that overlap box function. All right, so now I just want to show off kind of how I have my scripts organized. So basically I have everything under this ECS folder. So under here we see all our data components. So I have a total of 7 data components. I also have this tags folder, which has another 3 tags. So that's basically a total of 10 data components that we have. So we have 5 mono behavior and helper classes, and an additional 6 systems. So I have a total of 21 scripts in the ECS implementation, whereas if we go to just my regular flow field implementation, you'll see that I only have 6 scripts. So it's quite a difference for the number of scripts that I had to create for the ECS implementation compared to the standard mono behavior implementation. All right, so jumping into the code here, we're going to start with our first system, and this is the Initialize flow field system. And basically I'll scroll down a little bit here. You'll see that this system runs when we click the mouse button. So this is essentially what prompts the flow field to create a new flow field. We use an entity query, so we just call get entity query on a type of flow field controller data. So this is actually going to find all the entities in the scene with this flow field controller data component. Now this flow field data controller component is just attached to our grid controller here. So here we just set the grid size as well as the cell radius. Now in the update function, we just go to this flow field controller query and we call get singleton entity. And this is like kind of just like an oversimplification way of doing this because I know there's only going to be one flow field controller query in my game. That's basically how I have it designed. Of course, if we have 0 or more than 1, we're going to get an error when we call this get singleton entity function. So this is how we can actually get the flow field controller entity, get a reference to that there. Then using the entity manager, we can get the component data off that flow field data controller. And then once we have that, we can basically populate the values for this flow field data component. And this flow field data component is something that we're going to add to our flow field entity. Of course, if flow field entity equals entity.null, meaning that we do not already have a flow field entity, we're just going to go ahead and call create entity on the entity manager. And then here we can go ahead and add a flow field data component to that. One thing that we'll also do here is we'll set is existing flow field equal to false. Now normally we'll have this value set to true, and this is something that we're going to be referencing in the next system because we're going to be doing things a little bit different depending on if we already have a flow field initialized or not. And then lastly down here is where we just set the values for those data components on our flow field entity. All right, so next up is the Initialize flow field grid system. And this system takes care of 2 things at once. Basically what it does is it breaks up the world into a grid, and it also calls our helper cost function to set the cost field values for each of the cells. So up here in the onCreate function, I'm just going to go ahead and get a reference to the entity command buffer system. After that, I have a cell archetype, and I'll show you how to create an entity off this archetype later in the code. So now we go to the onUpdate function where we actually do just create a command buffer here, which we call command buffer. So now we're going to do an entities.forEach on every entity that has a new flow field data component and a flow field data component. Now the first thing that we're going to do is actually go ahead and remove that new flow field data component so we don't run this system every single frame. Now because we're using command buffers, we're actually not removing this component until the end of this lambda function. So even though we basically queue up the new flow field data for removal off of this entity, we can still access the data on it. And we actually are going to need to access the data a few times. And one of the times that we do that is actually right here. So here we're actually going to be creating what is known as a dynamic buffer. And a dynamic buffer is basically a container for a bunch of things. In this case, we're making a container of these entity buffer elements, and I can show you this entity buffer element class here, and it basically just has a public entity which we call entity, and it has some other associated functions that are necessary for converting the entity buffer element between an entity buffer element and an entity. And basically we use this dynamic buffer as a way to store all the cell entities that are associated with this flow field. So like I said, we're going to be using that new flow field data component, and we're going to see if it is an existing flow field. If it is an existing flow field, we're just going to go ahead and call the get buffer function, passing in the type of entity buffer element. Now if this is existing flow field is equal to false, then we're going to do a command buffer dot add buffer with a type of entity buffer element, again running that on the entity. So then we just store that in the variable called buffer right here. Next up, we're going to convert that dynamic buffer into a type of entity. So we're just going to say entity buffer is equal to buffer.reinterpret with a type of entity. And so this is going to allow us to add entities to this entity buffer. And the reason we're going to be doing this is because in another system, we're going to need to reference all those cell entities that are associated with this flow field. And so we can do that through this entity buffer. So very similar to the previous video, we're just going to do nested for loops over gridsize.x and gridsize.y. Here we'll just calculate the world position that our cell is going to be. Next up, we're going to calculate the cell cost using this cost field helper.instance.evaluate cost. And so I can just go over that real quick. Like I mentioned, this cost field helper, this is a mono behavior, and this evaluate cost function basically just uses the physics.overlap box at the world position to see if it collides with any of those things that are on either the impassable or terrain layers. And then from there, this basically just returns a byte value of either the max value if it's on the impassable layer, or a value of 5 if it collides with something on the terrain layer. So now here we'll just set up the new cell data component. All right, so now here's the other time that we're going to check if the flow field is existing. So if it is an existing flow field, we're going to find the flat index. Now the flat index is found with this toFlatIndex helper function that I've created. And basically what this does is it takes the XY coordinates as well as the height of the grid, and then from there it can calculate what the flat index will be. So we're actually going to be using this a number of times, and the reason for that is because there's some things like the entity buffer, which you'll see that I'm using right here, which we can't have two-dimensional arrays of. So the way that we work around that is we would do what's called flattening the array. So if we have a two-dimensional array, we basically just kind of flatten it out so it becomes a long one-dimensional array. And then when we want to find something at, say, position XY, we can use this toFlatIndex helper function, which I'll show you right here. It's very simple, and then that's how we can calculate what the index will be in this flat one-dimensional array. So then using this flat index, we can go to our entity buffer at the flat index and set this to the entity curcell. Now, if this is a brand new flow field, instead of what we're going to do is we're actually going to go ahead and create the entity based off of the cell archetype. So that's basically all we need to do to create something off an archetype is do create entity, and then we just pass in our archetype. It's extremely simple. And then we want to go ahead and add this entity to the entity buffer. So we'll just do entity buffer.add, passing in curcell. So basically the first time we run through the flow field, we're going to add all these new entities to this entity buffer. And then, the second and third time we come around, because we've already added these entities to the buffer, we can just look them up by index, and that's how we get a reference to them. And then once we have that, then we can do command buffer.set component, passing in the new cell data. So that's how we can set the world position, grid index, cost, and all that to that cell. And then so that is basically our nested for loop right there. And so again, that's going to break up the world into a grid, and it also sets up the cost field. Now after that, what we're going to do is we're going to find the destination index using this flow field helper.get cell index from world position. And here we can pass in the click position, which is again the mouse position that we clicked when we initially generate the flow field, as well as the grid size and cell diameter. So going back to the flow field helper class, this is basically just that get cell index from world position function. It's exactly the same way that I did in the previous video. Next up, I just set up a destination cell data component, passing in the index of the destination cell. And we're actually going to go ahead and add this component to the flow field entity. Again, if we already have the flow field entity, we're just going to set the values of it, no need to add it. And then the final thing that we're going to do is add the calculate flow field tag to our flow field entity. Now adding the calculate flow field tag is going to run the calculate flow field system, which is the next system that we're going to run through here. So now if we come into our scene here and we click somewhere, you'll see that basically we've populated this whole grid and it's created our cost field. So for example, you'll see that pretty much everything on this grass is going to be a 1. If we move over to this rough terrain, you're going to see that the cost is going to be 5. And if we move down to the impassable walls, this is where the cost is a value of 255. All right, so the calculate flow field system is going to take care of the other half of setting up our flow field. So what this is going to do is going to calculate the integration field as well as calculate the actual flow field. Now this is kind of one of those like kind of code smell things where I kind of like broke these two parts up into two systems. Like you'll see I have kind of that initializing the grid part of the system and this half of the system where I kind of like calculate and finalize everything. And I think actually ideally everything could kind of take place in one system, and then each of the kind of like major steps, like generating a cost field and then the integration field, those could actually all be jobified. And this is something that I was kind of looking into, but I felt like there was just way too much data that was being transferred back and forth, and it didn't really feel like it was all that efficient to me. Now that I'm kind of on the other side of all this development and I've cleaned up this code quite a bit from where it was, kind of when I started developing this all, I wonder if there are some ways that I can kind of jobify it. So if I do kind of revisit this flow field project in the dots implementation of it, that's definitely something that I would look into, is kind of like basically moving this all into one system and then creating different jobs for all the separate parts. All right, so again, of course, we're just going to go ahead and create a command buffer here. And then so what this is going to do is it's going to run on all the entities which have a dynamic buffer component. Again, that's kind of like our container for all the cell entities within our grid. Also on everything that has this flow field tag. We're also going to need a reference to the destination cell data as well as the flow field data component. So again, this is going to run on all the flow fields within our scene, and so typically we're only going to have one, but I tried to make this as extensible as possible in many areas so it would be easy. It wouldn't be something that I could do right away, but it would be easy to have multiple flow fields within a scene. So the first thing I'm going to do is just go ahead and remove that calculate flow field tag. Again, this tag basically tells this system to run, and we don't want this system running every frame. We only want it to run when we actually need to calculate the flow field. So we'll just go ahead and get rid of that. Again, we're just going to do this buffer.reinterpret so we can get a dynamic buffer of entities, again calling it entity buffer. And then here we're going to do a native array of type cell data called the cell data container, and we're going to allocate this to be the same length of our entity buffer. And we're going to do an allocator type of temp job. So basically what we're going to do here is just do a for loop, and we're going to go through everything within our entity buffer, and we're just going to call get component with a type of cell data, and then we're going to populate our cell data container native array. And then we can actually get a reference to the cell data component of the destination cell just by passing in the flat destination index into that cell data container native array. So here's where we're going to set the destination cell cost to 0 and the destination cell's best cost to 0. And because data components are considered value types, one thing that we need to do is just go ahead and reassign the destination cell, basically the new values of that back to destination cell container at position of the flat destination index. Next up, we're going to go ahead and create a native queue of int2 for indices to check. And then also we're going to go ahead and allocate a native list of neighbor indices. Now we're just going to go ahead and enqueue the destination index into our indices to check queue. And here's where we run the integration field. Again, this is pretty much exactly the same as it was in the previous video, and we're going to be running this while the indices to check count is greater than 0. So first we're just going to go ahead and dequeue that first element of the queue. We're going to get the flat index of it. We're also going to get the cur cell data by doing cur cell data container at position flat cell index. After that, we have this helper function, which just goes ahead and gets all the indices of the neighboring elements in any of the cardinal directions, so north, south, east, and west, relative to the current cell that we're on. And then here's where we just loop through those neighbor indices, and then we're going to be doing some comparisons on the cost of each cell. Again, if you do want some more information on that, definitely check out the first 2 videos in the series where I go a little bit more in depth on that, but it's exactly the same as before. So then once our while loop is complete, our integration field will be complete. So here's an example of the integration field. Again, same as before, we start at 0. And then going outwards, we're going to be increasing the values by the cost. So you'll see that the cost is going to be going up by 5 as we go across this rough terrain. And also looking at these impassable cells, this is going to be set to a really high number, indicating it as a cell that we cannot travel across. And then the final thing that we do is actually calculate the flow field. Again, calculating the flow field is extremely simple once we have the integration field. Basically what this is going to do is it's going to go to every cell in the grid, and it's going to check all the 8 cells surrounding it, and then it's going to find the cell with the lowest cost that it is next to it, and whichever one has the lowest cost, that's essentially the cell that it's going to point to. And then so that's how we can influence our entity movement. And then finally, we're just going to do a little bit of cleanup at the end, setting some components and disposing of some of these native containers that we have. And then finally, the last thing that we're going to do is add this complete flow field tag component. So that complete flow field tag is going to trigger the complete flow field system. And all the complete flow field system does is, of course, it's just going to go ahead and remove that tag because we don't want it to be running this every frame. And then I have this entity movement system.instance.set movement values. And then so that brings us over to our entity movement system. So you'll see that I have this set movement values. And this is a little bit of a messy function. It's just kind of like setting up a bunch of values so that we can have reference to them within the onUpdate function. And then here is the onUpdate function. Again, this is very similar to the unit movement in the previous video. Of course, a couple differences here is we're going to be jobifying this. So you'll see that we have a job handle. We'll set that equal to a new job handle. And then here we'll set job handle equal to entities.forEach. And this is going to be running on everything that has a physics velocity. We're going to need a reference to the physics velocity because we're going to be impacting the velocity of these entities. We're also going to need a reference to this entity movement data component that I have. And then finally, we're going to be referencing this translation component. So here we can do cur cell index, and we'll basically find what cell the particular entity is above. And then from there, we can get the move direction just by looking in our cell data container. Again, this is a native array of type cell data, looking at the flat cur cell index position and looking at the best direction on that particular cell. So basically this means wherever it is, we're going to look at the cell that is under it, and we're going to find the best direction. And then here we're just going to set the linear physics velocity in the X and Z axes equal to move direction multiplied by the final movement speed. And then one thing that I did, again, this is super hacky, but I'm setting translation.value in the Y direction equal to 0f, because if I didn't have this, I was basically running into a problem where all the units were converging on this one point, and they all just kind of like mashed together, and then eventually they just kind of like blow up and they'd all shoot upwards and downwards, and it looked really cool, but it was not the effect that I was going for. And unfortunately, doing this when I have a whole bunch of entities converge on one point, it does lead to a bunch of performance issues, which I'm really not too happy about. And the final thing that we're going to be doing is we're actually going to be scheduling these as parallel jobs, just passing in this job handle here, so then we can call job handle.complete, which just ensures these jobs complete before continuing on with the execution of the function. And so that is basically it. So now we can go ahead and generate our flow field here. We can spawn in a bunch of units, and we'll see that they all converge in on one point just as we like. Again, we can click anywhere on the grid, and it's always going to find the most efficient path to that destination. And you'll see that depending on kind of where these are, it's gonna come up with its own kind of unique path. Of course, we can spawn in like a bunch of these, and I can kind of show off some of these performance issues that I was mentioning. So you see when everything kind of converges on this one point, you see that the frame rate really dips down to the point of like, this is like less than a frame per second right now. So it does take a little bit to kind of figure its stuff out, but when it does, it kind of normalizes and starts to work a little bit better. But again, this is just kind of my hacky implementation of this. This is one of the reasons why I didn't want to make this a full-on tutorial video, because there are a couple things like that that are certainly not ideal to have. Again, I'm going to be doing kind of a performance comparison in the next video. So I'm going to be comparing the performance between the standard Unity mono behavior implementation, the data-oriented technology stack implementation, which I've done today. I'm probably going to do a little bit of cleanup on this because this performance is pretty terrible. And then I'm also going to be doing sort of like a hybrid between the standard mono behavior implementation as well as the Unity ECS implementation. And man, you'll see when all those entities are bunched up together like that, the performance is really not good. Let me just see kind of for laughs. So we have about 1,700 entities in the scene. You figure about 900 of them, 880 to be exact, are for the cells. So that kind of leaves, about 900 entities right here. So that's not like a crazy, ridiculous amount of entities or anything like that. Again, this probably comes down to my poor implementation of this as opposed to, a knock on the entity component system itself. But anyways, I think the numbers are really going to speak for themselves when I do that in the performance comparison video. So again, please subscribe to the channel so you don't miss that video. Of course, if you did find today's video enjoyable or useful at all, I'd really appreciate if you hit that like button. Also, if you do have any questions for me, suggestions for future videos, or just kind of want to chat about this implementation, you can do that down in the comment section below or over on our Discord channel, community, whatever you call it. You can just go over to tmg.dev/discord and come hang out with us over there. But anyways, I think that's going to wrap up today's video. So I hope you all have a fantastic rest of your day, and I'll see you in the next one.